Hello, my name is Emon, and today I will be doing a segment on density. Yeah, I got my full head of hair because I'm a scientist, and yeah, so today we're going to be doing density, my first concept for Mr. Mahlums' 9th grade honors science class. I will be explaining density to my full kind of knowing of it, and we will be doing some experiments on my trusty table of woodenness, and it should be a fun time. So let's do this. Alright, so density in physics is different than density in the real world. Like, if you're going to call somebody dense, that's more like calling them, like, stupid or compact. But if you're going to say something about density in the physical matter, the property of, like, density, first of all, you need to know that density is a physical property of matter. Now, each element and compound has a different amount of density. No matter how big that compound is going to be, it's always going to maintain the exact same amount of density. So, for example, let me get water. Hello. This cup of water, is filled up about, 3/4 of the way, but this bowl of water has way more water in it, so it has more volume than this one. So, yeah, it has more volume, but density will always stay the same. So, this might have, more water in it, but the water inside of this and the water inside of this will always maintain the exact same density. Now, that is true for not only water, but for every single compound or element in the world. This wood, because it's made out of the same kind of wood, this whole table is going to maintain the exact same amount of density. Now, maybe that table has different, like, metals or something screwed in it to make it stay, like, together, but the wood that it's made out of will always have the exact same amount of density. And once again, that's true for all kinds of compounds or elements. So to understand density, you need to know that. Because if I said that my fingernail has, like, this little fingernail has, like, 3 density. We're just going to put up a random number. And then my thumbnail is bigger than that nail, obviously. I can't say that that has a larger density, because it's the same element or compound, so it's going to have the exact same amount of density. So, that's the first thing you pretty much need to know about density. Alright, so I really think that density is usually used for the measure of how well something can float on a certain liquid. Now, all liquids, remember, have different volumes, or different densities, because they are all different elements or compounds. Water, which is a compound, because it's mixed of 2 elements, it's a compound. It has usually, well, actually always, about 1 gram per cubic centimeters of volume. Yes, 1 gram per cubic centimeters of volume. And that's its density. That's the amount of density in water. Now, if you ever hear about these oil spills from the Gulf Coast, you know that the oil will always be floating on top of the water, making all of our poor animals die. Now, if you think about this, you have to figure out that the water is probably more dense than the oil, because the oil is floating on top of the water. Now, wouldn't it just make sense that if the water has more density than the object floating on top of it? I mean, like, does that not make sense? Because it does make sense. Think about it like this. If I just like cut off one of my fingers and dropped it in the cup of water, it would obviously float because that object has less density than the water. Now, density is usually going to be smaller than water. Most objects in the world will be able to float on water. But in some cases, that's not true. Like, for example, the density of water is only 1 gram per cubic centimeters of volume. And if we're going to put, let's say, a huge steel brick into a huge amount of water, it's going to sink. Now that's once again because the object that's in the water has more density than the water. So to sum this all up, if your object has more density than the water, it's going to sink. But if the object has less density than the water, which would have to be probably in the decimal places, so like the tenth, the hundredth, that's where they would have to be by their number of density. That's going to make the object float. So remember, the less dense, it's going to float. The more dense, it's going to sink. Alright, so to apply this, not to me, but to like the world around us, for an example, we can use ice on water. Now everybody knows that ice floats on water, because, you know, how could half the icebergs be in the United States and around the Arctic Circle? That doesn't make sense if it couldn't. But did you know that this is an abnormal physical property of solid/liquid state of water? Now, I will explain this. The more normal physical property is for the solid compound of the liquid is for the solid compound of the liquid to sink in the liquid. So, for you guys to better understand this, I don't have ice right now because my mom didn't put the ice thing in the thing last night, but it's okay. We can still make do without it. To better understand this, if you have a glass of water and it's really warm, you're probably going to put ice in it to make it, you know, colder, and for you to better enjoy your glass drink. Now, you will always see the ice float on top of the water because usually and always the ice has less density than the water. Now, it makes no sense because shouldn't the water and the ice, which is made out of water, have the same amount of density? Well, in this case, no. So, if you're going to think about maybe one object in the whole entire universe that wouldn't have the exact same density of what it's made out of, it would be ice. So, I just wanted to say that. Just a fun fact. But yeah. Alright, so the density calculation can be kind of confusing, but you should always know that density equals mass over volume. So let's say this tennis ball weighed 10 grams, and it had a volume of 13 milliliters. Then I would just take the grams divided by the milliliters to get my answer. Now, if you get, let's say you get like 5. 5 is not your density. It would have to be 5 grams over milliliters to show that it has 5 grams per milliliters. Sorry about that. So 5 grams per milliliters. Having the over sign or the slash for division can also be like saying per. So that's pretty much a good concept you should know about density. and when you're calculating it. Now, if you have conversion factors that you need to find for finding your density, let's say it's let's say you're using the metric system with the U.S. standard system, like let's say you have grams and or pounds and milliliters. You would have to do a conversion for that, but you can still get the correct answer. And your density of your compound will always stay the same, remember, no matter what the weight and the volume was. Mass and the volume was. Okay, so yeah, so density, you know, it's a great thing. So far, you've learned about the calculation, so it's mass over volume equals density. You've learned about what it's used for, and it's most commonly used, once again, for when different materials interact, like a tennis ball and water. So, which one has the least amount of density? Or you can relate it to, you know, when you're swimming, you have less density, your body, than the water. So, another great way of explaining density, and giving an example, would be helium balloons. They float in the air, the atmosphere. So this isn't using liquids at all. It's using gases and a helium balloon. Because the density of the helium is lower than the density of the air, that balloon is going to float. So that's a cool little thing. Just to get more understandings, the person who discovered density he's kind of weird, you know. He was very interactive with the kings and of his land. I believe he tried to figure out if the king's crown was actually gold. And by doing so, he had a tub of water, and he put the crown in the tub of water and to see if it would float. Now, we should all know that gold does not float because it has more density than water. Gold, this is kind of a discovery in the gold rush in California. The gold was floating on the bottom of the like rivers or streams, and they would have to pan for the gold. Now, it's obviously going to be underwater, because if it had less density, then it would just float over the water, and everybody in the gold rush would have got rich. But practically nobody got rich because it was so hard to find. So, the guy who discovered density, his name started with an A, like I forget. But anyways, he was pretty smart because he knew that gold would have sinked into the water if it was real. So that's a nice kind of old-fashioned history lesson on density. And he was the one who discovered density. He ran through the streets screaming nonsense about density naked because he just had, you know, washed himself.